Yeah, yes, sir.
Recording has
Can you
started.
start?
Recording has
Yeah,
started.
yeah,
Just a
yeah,
second.
yes, sir.
Hi everyone, welcome to the INGR QIT uh, meeting, monthly meeting on 15th of every month. And we have Professor Gokhale, Radhika, myself, Prakash and Abhishek. And let me ask Abhishek to introduce himself. Go ahead, Abhishek. Thank you.
Yeah, yeah. Hi, hi.
Yeah. Mhm.
Good. In our place now, the good. I can say good night. And
Okay,
myself, Abhishek Mani Shukla, I have worked in the area of the free space optical communication and optical wireless communication.
fantastic.
From done PhD from IIT Patna.
Hmm.
After that, I have joined the IIT Delhi, where
Hmm.
I have work as a principal project scientist
Hmm.
for 1 year. And
Hmm.
after getting a lot of experience in the experimental setup of advanced optical communication test bed
Hmm.
and lab setup environment, how to do that and what is the future
Hmm.
aspect of the free space optical communications.
Hmm.
Getting that experience and working under Dr. Abhishek Dikshit, then
Hmm.
I came to after that I have joined QNU Labs. If you know, it's
Hmm.
a indigenous India
Hmm.
self-made company. You can say that it's
Hmm.
working a lot of good work in the quantum com side,
Hmm.
and where I am working as a quantum optics as a research associate. It's almost more 1 year, 1.5 year approximately. It's completed
Hmm.
now. And
Hmm.
currently, I am working in the DVQKT protocol, some improvement perspective, and another CVQ continuous variable QQD.
Hmm.
Is the my main project in which I am working in the from scratch to complete product level development part. That is the some brief
Background.
overview about myself, sir.
Fantastic, fantastic. We have a practical lab person who is really working on it,
Yeah, sir.
and welcome to you. So
Sure,
I
sure,
would
sir.
like at this time, because this is late night for you. Next week, next 15th, it will be 1 hour earlier because of the
Okay, sir.
changes. So it will not be
Yeah,
that
sure,
difficult.
sure. Currently, for my it's now
Yeah,
11:15
yeah, I understand.
p.m.
So that is why
Yeah,
we were not sure whether we should do it. But we said, let us do it as it is, so that next week it will be next 15th, it will be 1 hour less, so you can easily join.
sure,
So, how is Delhi?
sure,
Is it
sure.
cold today?
No,
Yeah.
no. Currently, sir, I am staying in Bangalore.
Oh, Bangalore. Okay. QNO.
Actually, I
Okay.
am the experimentalist person, so I have to work along with theory and experimental. All
Fantastic.
things I have to work along with that team, which is basically based on the Bangalore company, and some company persons are also staying in the Bangalore, Gurgaon.
Oh, okay. Okay. So, you do have people in Gurgaon, you mean, or Bangalore, Gurgaon?
No, no,
Bangalore
I
has,
am in Bangalore.
yeah, no, does
Bangalore.
Gurgaon has something in this QNO?
In Gurgaon, no, no, in Gurgaon, they have some DEFCOM where they are providing some defense related solution with
Okay.
QKD, which
Okay.
we are having some person, some PQC area person who is
Okay.
working in the post quantum cryptography. Those guys are there and they have some center of excellence. They
Hmm.
have set up there to
Hmm.
demonstration and some demo purpose and for
Hmm.
defense guys, some ministry like that they are doing there. But R&D, whatever, basically you can say ki pure
Hmm.
R&D things, whatever deep tech we are doing only, it's
Hmm.
doing on here in Bangalore only.
Fantastic, fantastic. So we
So
do. Mhm,
currently in our company, sir, I want to tell
mhm.
that ki we are having the QKD system point to point up to 40 dB loss, 200
Oh,
kilometer.
okay.
Across
200.
the world, few company only having that 200-kilometer QKD systems.
Oh, that's fantastic. 200 is the limit. Actually, 220 is the max I've heard. But if you can do
Yeah,
200, that is, or
yeah,
even
sir.
more,
That depend. Yeah, that it depend upon the. Some people have
repeaters.
used some ultra low loss fiber. If you
Uh-huh.
are having some ultra low loss fiber, currently we are using some conventional single mode
Conventional.
fiber standard, which we are
Okay.
using
Hmm.
already installed in the infrastructure that we are using. And so if we will have some ultra low loss fiber with respect to currently people are having 0.16 dB per kilometer loss fiber. If we will
Uh-huh.
have that much, then it's not a big challenge. We can go up
Okay.
to 220 kilometer.
Correct.
Yeah.
Correct.
So,
Excellent.
sir, actually, I also want to know everybody.
Yeah. Yeah. Okay.
Recently I
Let's
have
do one
joined
thing.
in this.
Let's start with Gokhale. Gokhale. Just a second. Somebody else is also joining. Let me. Uh, Sunil Kumar is joining. Let me have him. Sunil. Sunil, are you in?
Yeah, I'm here.
Very good, very good. So, Sunil, we have Abhishek Mani Shukla here from Bangalore, QNU. He introduced
Okay.
himself, and his background is he's in the quantum and working on the what do you call the optical uh, fiber,
Free space optics.
free space optics. Yeah.
No,
So
no.
free.
Currently, sir, I am working in the quantum optics and
Mhm,
CVQKD protocol. That is the my project which I am leading.
mhm.
And
Fantastic.
in that project, I am working currently. And my previous research
Mhm.
area focus in the free space optical communication. That I have almost 2 years.
Mhm.
From 2 years, I am working in the quantum key distribution area, quantum com side.
Yeah. So quantum communication is your forte, basically, with the optics,
Yeah,
free
yeah,
space
with the
optics.
optics.
Yeah, and the free space optics can also be used between the LEO satellite and
Yeah,
any of the drones and or air taxis and all that, right? That's also a use
yes,
case,
sir.
possibly.
Yeah, yeah. Yes, sir. Correct. Free space
So,
and fiber also, that
fine.
optical fiber communication. In my
Mhm.
PhD, I have worked in the OM modes, orbital angular momentum OM modes,
Oh,
high
orbital angle.
dimensional modes. I have utilized to increase the capacity of the link in free space and even in fiber, few mode fiber or multi-mode fiber.
Multimode fiber,
That
yeah.
I have, yeah.
Yeah, these so you can use compression to expand the capacity, or you can use better quality fiber. Those are the two options. Obviously, the also depends upon how the topology of uh, the free space we can capitalize on, right?
Yeah, actually, it depends upon the application where what you want to use. So
Correct.
currently in optical communication, people are increasing the capacity using some different
Mm.
uh, degree of dimension. Suppose currently, previously people have used polarization domain multiplexing, then
Mhm.
wavelength division multiplexing came to in picture,
Mm.
and after that, now the due to the limitation of the Shannon capacity theorem,
Correct.
that will limit the capacity of your channel. Now people are start using the spatial division multiplexing.
Mhm. So, uh, uh, Abhishek, you are there. What happened to Sunil? Oh, Sunil got disconnected or what? I don't know. Okay. In the meantime, let's ask Gokhale to. Uh, Gokhale, were you able to receive any return message on your email to approve it?
Just hold on, let me check out.
Yeah. So if you sent it, you should get a message to approve it. If you get approve message to approve
I've
it, then
sent it. I've
yeah, go
sent
ahead.
it, but I did not get
Okay,
any reply.
okay, no problem. Just with Radhika, can you check if you got in the
There's
meantime?
something wrong with the video. Sorry, with
Is
the
it okay
network.
now? Yeah, there is
Yeah, I'm back.
something wrong. You are back. So
Yeah, I'm back.
let's do one thing. Let's ask uh, Sunil to introduce himself because Abhishek wants to know about everybody. So just Sunil,
Yeah,
go
hi.
ahead.
Can you hear me? Am I audible?
Yeah, you are audible. Just brief introduction that should do.
Yeah,
Yeah.
yeah, sure. My name is Sunil, and I basically with Nokia. I work in the private wireless space in the basically campus networks or in the 5G and advanced 5G space. So um, I have basically a bit of background in AI/ML as well, having done a program from MIT on product and solutions design some time back. And we work across the industry in terms of mining, manufacturing, defense, transportation, railways, for example, and also energy in terms of oil and gas and other industries as well. Thank you.
Super. Thanks, Sunil, for joining again. I will go to now Gokhale, who is the new chair for the IEEE QIT working group. Go ahead, Gokhale. Introduce yourself.
Hello everyone. Hello everyone. I hope I'm audible.
Yes, you
This
are.
is Gokhale Jayanti. Yeah, I'm signing in from Mumbai, and I'm a new entrant into this QIT working group. Even though I've been working on several aspects of IEEE quantum-related activities. Once again, I've been working closely with Prakash. I'm primarily an academician with some inclination towards doing some independent research, taking some kids with me all along. I'm associated with a bunch of colleges with Mumbai University. I'm not working with Mumbai University though, but I'm associated with a couple of colleges with Mumbai University. And my area of interest presently still happens to be a bit of quantum machine learning and reading up a bunch of things here and there, and then trying to see if at all I can probably put something to practice in the area of let's say uh, uh, quantum CNNs, quantum convolutional neural networks. That is what I was trying to toy around with the idea. So I really am not an industry guy at this particular point of time, but let us see if there is some form of a use case that is uh, cooking up somewhere. Maybe we can just sit down and then contribute towards that as well. So that's a very quick and a brief introduction about myself.
Yeah, you can share your LinkedIn in or whatever if you
Yeah,
have
I'll do
any.
that. I'll do that. I'll do that. My LinkedIn profile needs a little bit of tweaking around and buffering and I should say revamping. I've just started with that. Maybe give me another day and I'll complete that task.
Okay, so we will have his. And in the meantime, Radhika, I think, bumped off. Maybe she will come back. But in the meantime, I'll introduce myself so that you people are aware. I am the co-chair. I call it co-chair because there is a chair and co-chair, but generally we have been using the co-chair term for if you have more than one. So Quantum Information Technology, QIT working group, I have been chairing for almost now 3 years. And September 23 or 23, yeah, 23 it was when we started, when we got approval and we proceeded to do that. And we had first meeting in the what do you call Seattle, where it was IEEE Quantum Week, where we met and we formed the group. And then after that we continued with the roadmap activity. We finished the roadmap activity as of first release, and we reviewed it and we have submitted it. The last meeting we had was in Bangalore.
An activation
Yeah.
function, and it's chosen to perform linear function.
What happened? Anybody something? Okay, so last meeting we had at Bangalore, and of course we had monthly one more meeting after that, but mainly we focused on the what do you call there is a direction for the IEEE INGR working group to align with what you call 6G, and 6G is still in the air, in the sense it is still not there, even though 6G releases, 5G advanced releases are in what you call in somewhat experimental mode. So depending on that, there is IMT 230 which was provided to us to align, and we had a couple of things which I think Sunil also helped us shape in the ICAS, that is the integrated communication and sensing area, which is used by most of the disaster and disaster management use cases for acceleration. And so there is a concept of acceleration, there is a concept of sensing and responding back, all using the acceleration using quantum, because that can speed up. And also there is a concept of security, of securing the communication through use of quantum qubits, through superposition as well as entanglement, and that's one thing to establish the channel. But once the channels are established, then we know that there is no what you call interference, then they can go on to communicate what they need to do. So these are some of the PQC. We had the last year all the essential quantum presentations, including, in fact, it was a panel. We had one for quantum, what do you call, post-quantum cryptography. Then we had one for quantum key distribution and one for the, what do you call, the QKD. So key distribution, QML, and post-quantum cryptography. And we have done all that is required from at least a dozen of professors and industry practitioners. So we have those available on the channel, which I'll share with you. And so that is it. So let me see, let me ask if I can get, what you call, Radhika on, just a second. Let me see if she's able to join. If there is anything that held her, or is she in a meeting or something? And there will be no meeting, right? This is late night there in India, so I don't think it is because of that. I had to leave the meeting. Okay, sorry, sir, I had to leave the meeting. Okay, so give you just brief background about Radhika. She is a what you call, she is a professor in doctor in mathematics from Hyderabad, BITS Hyderabad, BITS Bilani Hyderabad branch, and she has been our mathematical guru for the various things. So at this time, I would introduce to you to her later. And so Sunil is aware of it because Sunil worked with her on one of the proposals. So that is on the QIT quantum's approach towards the what we want to do in these coming years. So Gokhale, I would like Sunil to say something about what the QIT approach was for the quantum, and you can add to that or at least absorb what he had. Yeah. Sunil, you are waiting in the lobby. Why? Okay. Maybe.
No, no,
I thought. Okay. Oh, it looks like you're double.
no. What happened is I got disconnected, and then
Okay. No problem.
I
So
tried to join through my mobile. Sorry.
just describe about the um, presentation we have submitted. If you want, I can share the one
Yes,
slide. Yeah, just a second. Let me see. Or you have the slides?
I have it. Incidentally, I have it open.
Yeah,
Let
if you
me
have
just.
opened it, just that one slide which has the blue circle, that should suffice for us to
Correct.
make
I'm
a.
just trying to find. I'm just trying to
No,
find the uh,
yeah, if needed,
WebEx. WebEx suddenly disappeared from my screen.
no,
Just a
no
second.
problem. There I have the
Share my
pad.
screen. Share. Okay. Share screen.
Mhm.
Okay. Are you able to see my screen? So
Just
far, so good. Is it any
uh,
time share?
that's good. How quantum information technology QIT enhances next generation wireless roadmap. Yeah, sure. Go ahead. That blue one. Yeah, first, second and third. That's all. You speak about second and third. That should suffice. Yeah. So next slide. The guidelines the Frederica provided us. Go ahead. Yeah. Are you there, Sunil? What group's content you shared? Yeah. Sunil, if you want, I can share. If that is the case, let me see. If I have it, then I can share. So it was QLabs, right? QLabs proposal, yeah. And then under that, I have just hold on, okay, everybody. If you are not hearing anything from Sunil, we can do one thing. What is it? You're already got. What is it? Abhishek? Yeah, looks like. Oh, Sunil again. Okay, no problem. Let him. His screen froze, it appears. Message to everyone saved. View. Okay, let me just get him in again. Okay, so the problem was his. Yeah, this is the problem with WebEx anyway. Yeah. So
I'm
are you
very
there,
sorry.
Sunil? Yeah, no
Yes.
problem.
Yeah.
So
Let me
we
share
if you
again.
want, you're sharing? Okay, good.
Yeah. Let me share. Hopefully it will be stable now.
Yeah.
Just let me know when you can stream my screen, and or you
Yeah,
can
we can
even message in the
see
chat.
we can see your screen.
Yeah.
Working now? Okay.
Yeah.
So,
It's
yeah. So we basically, finally. So we basically try to put something together in terms of how the quantum information technology would overall influence, or um, kind of impact, and have a kind of influence on the INGR roadmap that we're working on currently. We're all familiar with this 6G architecture and the leverage
Hold a second. International Next Generation Roadmap, INGR, that is it stands for. Yeah, go ahead.
Correct. Exactly. Yeah. INGR is part of the FNWF, basically. So it is synonymously used. Yeah. The Future Network Working Forum. The
World
IEEE
Forum.
Future Network Working Forum.
World Forum. World Forum.
Yeah. Yeah, World Forum. The IEEE Future Networks World Forum.
This is all part of ComSoc. So at this time,
not part of ComSoc. These are the several verticals that are there as part of the INGR.
What I mean is the major funding for the INGR currently comes from ComSoc. There are other societies, but mainly it is a ComSoc driven. Okay, that's why we communication. Yeah, go ahead.
Right.
Next.
Exactly. Okay, thanks. So, then we basically have the IMT 2030, which is the standards body similar to 3GPP standards, and we basically have an evolving and an evolutionary and a revolutionary capability for 6G, right? So, essentially, what we are looking at is basically the enhanced mobile broadband and URLLC and MMTC in the case of 5G and 5G advanced, and that was typically IMT 2020 or so. And you can see that these ones that are there in the green have evolved from the 5G space. So this one here and here have basically evolved from 5G in terms of providing immersive communication, much higher throughput, bandwidth capabilities, etc., and so on. And then there is also the revolutionary capabilities, which is basically the new capabilities of 6G, which have come into the picture. So those are basically in terms of having AI at every layer of integration in the 6G assets. So we call it as AI native or integrated AI in communications. Then there is the ubiquitous connectivity, that is having a seamless connectivity between both terrestrial and non-terrestrial networks, and being able to use security aspects also from quantum going forward in the same. And Gokul just mentioned about the use of quantum CNN, quantum neural networks, etc., and so on, which will probably take some more time to come in terms of the stability, and once we have the stable qubits and so on. But then that would basically also add to the overall capabilities of this, especially in the areas of medicine, and also in areas. I think you know best because you've been in the QNU labs, and you probably also have been working on some of these areas as well. And then there is the very unique aspect of, rather the more flavor of 6G, basically, which is typically the integrated sensing and communication, where your network itself kind of becomes like the radar in terms of being able to seamlessly fetch information, along with being able to provide the RF connectivity and communication and radio signals as such. But they also behave like a sensor, so it's the sense, think, and act, basically, as far as the network is concerned, right? So if you look at the picture on the right, you have these 6 new capabilities of IMT 2030, which is basically in terms of the coverage, the sensing related capabilities, which is ISAC, as we spoke about. And then you have the one thing I missed out here is the massive machine communication, so MMTC. So it's again evolved to provide a million it is basically 10 million devices in 1 square kilometer of area, basically, and so on, right? So compared to 5G, which is typically a 1 million device kind of thing. And then the average life of these devices are also significantly enhanced in terms of their battery life and so on. And so it's typically, it was to be 10 years, but it is now a lot more than that when it comes to 6G, because of the concept of ambient IoT and some of those areas as well, right? So let me know if there's any area which you want me to elaborate on, and I can probably do that. I'm assuming that you probably have some idea about this topic, and you're also familiar with 6G and have come across these 6G standards in some form or the other earlier, right? So the intent here is to kind of link the quantum capabilities and what we're trying to do here with the QIT team with respect to the roadmap for the confluence between the IML, quantum, and the rest of it, right? So then you have, there is a recorded session, you can have a look at it offline, but I'll quickly kind of run through this. And then there is this, so the coverage aspect is one aspect. It is better coverage, obviously, because of the terahertz capabilities which you have in 6G. Of course, the spectrum has to be made available by the regulatory authorities and the government, and some of the spectrum agencies, etc., the FCC and other regulatory bodies as such. Then there is this AI-related, then there's this AI-related capabilities, which we talked about in terms of being AI native architecture, because in 5G and 5G Advanced, when it comes to release 15 of the 3GPP standards and release 16, 17, etc., it was more of a interwork and evolve kind of thing, right? Which means that it was more of a top-up or a add-on kind of facility on top of the on top of the functional entities or the solutions and so on and so forth, right? Whereas when it comes to 6G, it is basically built in or stitched into the integral aspect of every functional entity, or every layer of the 6G, right, from the physical aspect, from the networking aspect, data aspect, and transport and so on, right? So typically that's the change in terms of how the AI has evolved or will evolve as we go into the release 21 and release 20 and 21 of the 3GPP standards, right? Then there is the sustainability aspect. Of course, there are a lot of areas in terms of how the capabilities of the network itself enable to the channel interference, the radio beamforming capabilities, as well as also the massive MIMO capabilities, etc., which we call multiple input, multiple output, the way the beams are formed, and also being able to switch off the radio stations when they are not being used proactively as such, right? So there are issues there with respect to how these happen when there is conflict, basically, because especially in the case of ORAN, when you look at ORAN, which is one of the capabilities of Open RAN, we call it, which is one of the areas in the radio networks. There are conflicts in terms of how one cell site will think that there is another which is not being used and try to switch it off, while the other one would probably feel that there is a person or a network handover happening over there, and so trying to increase the signal strength over there and so on, right? So the near RICs and the non-real RTs, etc., and so on will have their own challenges there. But anyway, we're not going there in this discussion. So then the interoperability aspect, the positioning aspect of it in terms of being able to detect an asset in a factory floor, for example, at a centimeter level of granularity or a precision in terms of how these indoor positioning systems or high accuracy, both indoor positioning and as well as external positioning systems happen. This can be a significant impact in the defense area, especially when we want to have targeted impact when it comes to some of these target points in terms of some of the both on in the battlefield, or also basically in remotely being able to do that. We saw that some of these capabilities in the recent engagements that we have been watching across the globe in the geopolitical situation that we are coming across. So, and the other enhanced capabilities which are coming from 5G, but more enhanced, more evolved. So these are the revolutionary capabilities, and these are the green ones are the evolutionary ones. So the security, privacy aspect, and resilience, where we have a big role to play from a quantum computing point of view, whatever Prakash ji was just mentioning a few minutes back in terms of the post-quantum cryptography, the zero day vulnerability and so on and so forth, right? So then you have the reliability aspect, the latency, the mobility aspect, right? So these are some things which are basically coming from the hyper reliable low latency communication, and having 6 nines reliable capabilities there. And then you have the mobility aspect in terms of autonomous cars being able to detect another autonomous car across the corner, and that's made possible through some of these things like integrated sensing and communication. The fog situations where basically you're not having zero visibility, where the radio networks can play a role in terms of detecting unseen objects or unknown entities which cannot be detected by regular camera or CCTV, etc., and so on, right? So to avoid kind of catastrophic situations and potential hazards and so on, right? So and then you had the connection density aspects and some of these things. I won't go into each and every aspect of it because it's quite in detail in itself, but then at least we know that there is a much higher data peak rate. So it's more of an ecosystem evolving from 5G itself as an ecosystem, but in case of 6G, it is more the human interaction and the sensing capabilities and the physical, the human, and the abstract AI and the technology aspect of it coming together as well, right? So that's basically what happens when you kind of zoom in and try to look at the specific areas in terms of security and trust, where you have the enhanced security and trust for the using quantum key distribution and post-quantum cryptography, where you secure your 6G quantum threats and data privacy aspects, which is possible if we start early. We know the HNDL scenarios, and we know the harvest now decrypt later scenarios, which are basically already in vast progress across the globe and so on. So then there is this network optimization and extreme connectivity aspect. So the quantum algorithms will help us solve these complex resource allocation issues, the radio channel interference, the channel space integrated CSI, basically we call it, and then the allocation and routing aspects, the optimizing of the spectrum, etc., the dynamic management for the 6G and that sort of thing, right? So that is another area where you can basically look at how the quantum quantum computing and quantum communications will play a big role in terms of how these things evolve as well, right? So 6G and quantum have a long way to go in terms of AI and machine learning aspects. The other aspects in terms of the network optimization, the enhanced security aspects, the AI native networks, which will basically boost the performance of the AI-driven autonomous network management, right? Today, there are level 1, level 2, level 3, level 4 autonomous networks, and many companies and many organizations are trying to kind of get level 4 autonomous network certified as such, right? So so from that context, so we were talking about the dynamic spectrum management, etc., and so on. So from that context, we have the QML based predictive maintenance, the intelligent traffic steering, data analytics aspect of quantum machine learning for cognitive, automated and specialized AI native architecture as well. So, like I was saying, these quantum machine learning will boost this, AI-driven, because it's concept of both networks for AI and AI for networks. So the network is basically helping the AI algorithms and the modeling at the grassroots level, and then the AI in turn is enhancing the network capabilities as well, right? So that basically kind of helps there, and quantum machine learning adds to the overall capabilities there when you have a stable working logical qubits, etc., which allows predictive maintenance, intelligent traffic steering, and data analytics as such. And the positioning we already talked about in terms of quantum enhanced location services and centimeter level indoor accuracy and so on and so forth, right? So 6G is kind of projected to come in 2029, 2030, as we know. But the integration of these technologies is still in a very early development, because study phase is over, and then we are into standards very shortly in terms of documenting the standards for 6G. So with all of these hardware limitations also exist with kind of this focus areas include, kind of having a robust energy efficient algorithms. How much do you want to have a trade-off between AIML or machine learning algorithms in the network, as compared to what outcome or objective they are going to be achieving at the end of the day, right? So if the trade-off is in terms of excessive energy consumption to achieve a saving of not being able to kind of justify that, then there is always a trade-off in terms of how you want to think. So maybe we can discuss this in a different day on a different topic, but we'll need to keep that also in mind, and in terms of how much of processing power in terms of the quantum, both at the edge network and also at the central processing systems, will have to be something which we can consider as well. Should I stop here, Prakash, or should I go to the next one?
Yeah, you can complete it since you have done. Just breeze through this.
Yeah, so this is the roadmap for the 3GPP AI introduction. So here, basically, you can look at the 5G advanced and the IML capabilities, how they have been evolving from release 19 to 20 and then 21, which is not yet in place, but we are basically somewhere here in terms of the 5G advanced and the 6G study item. So we started, like I said, with AI-powered optimization of the radio channels and so on as one of the capabilities for 5G and 5G advanced, excuse me. And then we have the AI-based millimeter wave beam management, like I was talking about, in terms of accuracy of the beam, in terms of how you want to ensure, especially in countries like Australia, etc., and so on. There are a lot of rural population which is very sparsely populated as well, right? So you can easily shut off these base stations in the night and conserve energy if there is not much activity in specific farmlands or deserts or whatever areas, right? So, but at the same time, you also need to see how you manage the switchover capabilities and so on. And then you have the location tracking accuracy, especially the fleet management and that sort of requirements as well. And the channel state interference, which I talked about in terms of the feedback enhancement, in terms of enhancing the quality of the, reducing the crosstalk or reducing the interchannel interference, and the signal to improving the signal to noise ratio at the same time, right? Then you have the release 19, which is like, so you can see the AI powered to AI coordinated to AI native. So that's the roadmap that it is taking. So we'll have to kind of stitch the quantum story to it and see how the quantum part of it also kind of scales up. Maybe probably 2035 or so, we will have some sort of kind of interaction there and integrated quantum and communication networks especially, right? So the device and cloud APIs, they have been around for some time over the last 4-5 years. We know that the cloud native architectures have been evolving as we speak. So that is there. And then the device and network exchange aspect also is something which will probably be part of the 2021 area. This is a typical example of an ISAC network as a sensor where you have the reflections across the thing. So you have a rich communication suite capable of sensing the target and using the sensing transmission with a massive MIMO antenna, which will allow you to gather this data from multiple sources from scattering and thing. And that's where the AI part comes into picture in terms of trying to both have the near field communication and also the non-real-time RICs, RACs they call it basically, right? So you can study the radiation pattern And these are reflective intelligent surfaces which can allow you to kind of play with the actual waveform, etc., and so on. And then it can take you to the central processing unit, which can allow you to process it both at the edge or at the central station. So you're basically seeing sub 6 gigahertz signals, and you have the new band signal, etc., and so on. Right? So this is something that you have. And so if you look at the typical characteristics of 6G, you have the ubiquitous connectivity, you have the AI and communication integration, the ISAC we talked about. Prakash also mentioned that. Then you have the semantic and intent-based communication. So what does this do? Basically, it bridges the digital divide. So we're talking about connecting the unconnected, right? Especially the rural population, the ones in the hill, mountainous region, mountainous terrain, or in the desert areas, etc., and so on, the borders of our country, for example. So it kind of bridges the digital divide and enhancing connectivity with underserved rural population, the remote and sparsely populated areas. But the use cases would be typically in terms of the IoT, the ambient IoT, and similar stuff, and then the broadband in the rural regions and so on, right? So ensuring that some of the SDG goals are met, the Sustainability Development Goals, the ESG goals are being met, basically, right? Out of the 19 United Nations goals as well, right? So one of them is information and the communication aspects. Then there is the AI and communication integration. So there you have the autonomous driving, which is very critical, the medical device collaboration. So especially when you are doing a surgery in a remote village, the doctor or the surgeon is in the city, and then you have to ensure a very high accurate reliability is ensured. You have concepts like network slicing, which allow you to have better quality of services, and you have hospitals and organizations who are willing to pay more as compared to a regular connectivity that they would take depending on the nature of the network slice, right? So these network slices are seamless in some cases they are end-to-end, which is right from the radio, the transport, the core and the transport networks, etc., the IP backbone and so on. So you have to ensure that the end-to-end reliability is there, so that when the surgeon is trying to make a cataract surgery for an old lady somewhere in the village, the forceps or whatever the device that is using, the robotic arms should not should have real-time capabilities to be able to have a smooth uneventful operation as such, right? So that's very important in terms of the connectivity aspects, the medical device collaboration and so on. The digital twins allow us to do a lot on the factory floors, in the medical lines, in the defense areas. We have these concepts, which allows to create a digital copy of a physical environment, allowing you to vary the parameters and observe whether they change over the implementation of small changes, etc. How do they impact the real network before they actually get rolled out in the actual networks, right? Then there are collaborative robots and so on, right? There is the ISAC part we talked about in terms of high precision positioning, localization, mapping for the extended reality, especially in a stadium, for example, the cricket match which happened today. You could actually probably have in the future see the view of what the actual batsman or the bowler is, kind of looking at in terms of the field thing, apart from what you're seeing from the boundary or from the other cameras, right? So it's already in place in the NHL, NFL, and some of these other forums, right? And then there's the digital twin applications, basically. So the navigation, motion tracking, today defense is a big topic. So we do a lot of work in that space as well. And then environmental monitoring of the pollution detection, etc., and so on, potential landslides, calamities, and so on, right? So fundamental shift in how communication is happening from semantic intent-based communication point of view, where you don't need to transmit every possible bit to be able to communicate what it is. So you're basically saving on the Shannon limit, Shannon's model, in terms of the semantic. You can actually send a condensed meaning of or intent what you want to communicate. So it kind of drastically reduces the bandwidth and also the power usage while improving the effectiveness of the communication, right? So when you come to ISAC, the key concept, how it works, there is a concept of passive sensing, there's active sensing, the AI and signal processing aspect, the traditional sensor networks, etc., and so on. So I wouldn't go too much into it, but maybe in the interest of time, because it's already close to midnight at my place here. Yeah. So, and then you have the smart cities, the healthcare, the security, industrial IoT, and virtual augmented reality. So these are the typical application use cases when you come to ISAC or the use of ISAC. And then we talked about AI for networks and networks for AI, where you can actually improve the network efficiency, security, and management, while the networks for AI allow you to have better AI applications with large data sets and real-time processing for these networks as well. And then the network itself becomes a platform. So network as a platform is an application use case, is a potential use case in the future. I'll stop here. Yeah, Prakash.
Excellent. Sunil Kumar, that was a great presentation, and I hope Abhishek Mani learned a lot. So did we. For me, it is, I think, second or third time. Gokhale also has gone through. So
Yeah, sir,
what?
sure.
Yeah, Abhishek, go ahead. Do you have any comments on this and anything
No,
you?
it's a,
If you would like
it's a
to,
good
yeah.
overview to understanding the how the 6G is going to work along with AI models and IoT networks like that. It's a good IJAC in current scenario. It's a very big boom and new research area where we people are working and have started working on that side. So it's a good learning and good understanding. Yeah, nice presentation.
Yeah, if you have any presentation, you can bring to the next next presentation on 15th, same 15th, but it will be 1 hour earlier. If you have any.
In 15th March.
Yeah, 15th March. That's right.
Yeah, sure. I will try to do that, sir. Sure.
Yeah, you try to do that if you can. And in the meantime, I'll just, the changes have occurred that this, because I am tied up with some of my, what you call, daughter's work. So I'm little keeping away from being able to do anything much. But I hope that Gokhale and Radhika and Chintan will also contribute along with us to get to the requirement what we want to fulfill for roadmap. And there is one area where Gokhale mentioned, I forgot to tell you. See, we do have quantum from compute point of view as well as communication point of view, and besides that, sensing and integration with AI and all that. But at the low end, in the sense to produce a qubit which is long lasting, there is a diamond technology. Diamond, they call it nitrogen vacancy, and we do have some experts who believe that the semiconductor qubits, which is SQUID we call it, will probably be facing good challenge from that nitrogen vacancy technology, which Australia, New South Wales or somewhere, they have already done some really what do you call, extending the capability of the coherence to a longer time beyond a towards milliseconds. So that's very good news, and hopefully we will hear in the market on those areas. So we would like to add that to the portion of acceleration which we have in the roadmap. So hopefully that I will ask Gokhale to do some survey, and probably he can bring that aspects as well. And nitrogen vacancy is more of a chemical bonding and ionization and all those things. So maybe photonics area we'll find some professor or somebody who can throw some light on that. So we will continue this every 15th. And I think being late today, I think we should end the call here. But thank you everyone for joining, and we'll have a recording of this added to the IEEE QIT, and then once it is ready, I'll send the link to everyone and send the summary. Hopefully, I'll ask Gokhale to do that this time, so that we can probably see some change in the leadership here. At the same time, enable other people to also bring more to the table. With that, I will call for last. Anybody, any comments?
So
Anything?
thank you for this session today, and I think we'll need to get more people who can join, and
Sure.
then we can probably have this
Yeah.
little more wider audience, a little earlier in the day, like you said. But I
Yeah.
think today
Yeah.
is
That's why
Shivratri.
1 hour earlier. 1 hour earlier next week. Next 15th will do.
Yeah.
And plus, you
Today
remember
is fine.
also.
Today is okay. Today is
Today
Shivratri.
is
Yeah, on a
Oh,
on a different note. But yeah, happy Shivratri to all of you. Mahashivratri to all of you. Yeah.
Mani, so let's. Should we call Abhishek or Mani Shukla Iyer or what do you call you? Most people call you Abhishek. I think so. He's done. And anyway, we'll close the call here. With that, I will stop the recording and.
Yeah, sure.